Hello, my name is Bermet Saparaliva, and in this video I will compare two capital budgeting approaches, Project A and Project B, using the cumulative present value approach. So both of the projects require an initial investment of $50,000 and they will generate different cash flows over 5 years. And the discount range, as I did in the Excel sheet, is 10%, which is 0.1, and I will show how to calculate the present value PV of each cash flow and the cumulative present value, so CPV, for each year, and then decide which project is better. So firstly, let me fill the years, number of the years. We have 0 and 1, 2, 3, 4, and 5th year. And then here I will write the cash flows for project A is minus $50,000. For year 1 is $10,000. For year 2 is $15,000. For year 3 is $20,000. For year 4 is $25,000. For year 5 is $50,000. No, sorry. For year 5 is $10,000 actually. So for year 5 is $10,000, and then I will keep 2 other blanks so we can fill the present value for project A, and then here we'll keep to calculate CPV in the future for project A, and then here we'll write same for project B, the cash flows that was given before. For first it's minus $50,000, first year is $5,000, and then $10,000, $15,000, $30,000, and we have $20,000 for year 5. So after that, I will leave another blank, and here I'll write the present value for project B and calculate CPV for project B. That's why we cannot compare these cash flows directly, because money received in the future is worth less than the money today. So that is why we discount each year's cash flow using the 10% discount rate. And the formula for the 10% value is going to be PV cash flow divided by 1 plus the discount rate and to the power of the year. So this is the formula that we got. Now for the project A, we will type the same formula, just apply it for the present value for project A. And okay, so now we'll just drag the same down to year 5 to get all the presents for project A. Yeah, so we got all the things that we need in project A. Now we go to B. Same thing, I write the formula. So I just repeat the whole process. Okay, and here's you. Okay, here we go, and we'll just drag it down so you're gonna see all of them. Now we have the discounted cash flows. So for example, for the $10,000 in year 1, for project A becomes about $9,000, 91 almost in the present value. The $30 in year 4 for project B becomes almost $20,490 after discounting. So this shows us how future cash flows are reduced when we apply the 10% discount rate. So the next step is to calculate the CPV, so the cumulative present value. The CPV will show the returning total of the present value over time, It will allow us to see in which year the project breaks even and how much value it creates by the end of the horizon. So in for the project A, we are going to be counting right now the CPV, right? So the cumulative present value. So for project A in the cell D3, it's going to be equal to the present value in year 0. And the same is going to be for others. For year 1, I'll just sum present value in year 0 and the CPV. So T3 plus C4. And then I'll just drag it down for all of them. And then we can do the same for the project B. So we're gonna have minus 50,000 here, and then we'll just sum CPV in project B and the PV in B, and we'll drag it down. So now we can interpret the results. For project A, the cumulative present value starts at minus 50,000 and becomes positive between year 3 and 4. And by the end of year 5, the CPV of project A is about $9,800, which means it creates that much value in present value terms. So for project B, the cumulative present value becomes positive only between year 4 and year 5 and reaches about $6,900 by year 5. So both projects add value, but project A generates a higher cumulative present value and reaches the break-even point earlier. So now let me copy the years and the CP of A project and CPV of B project. In the MacBook, it's a little bit different. So we can put them all in one and make up them as a table. So what we're gonna do right now is create a line chart. So this is gonna be the line chart for the cumulative present values. So the x-axis shows the terms from 0 to 1 years, and the y-axis shows the cumulative present values in dollars. So the blue line is gonna represent project A, and the orange one is gonna represent project B. And we can clearly see that the project A's line crosses 0 earlier and ends with a higher CPV than project B. So that can confirm that project A recovers its investment sooner and creates more value over the 5-year period. So to conclude, using a 10% discount rate and the cumulative present value method, both projects appear acceptable because their cumulative present value are positive at the end of year 5. But project A has a higher final cumulative present value of about $9,848, while project B has only $6,900, and project A becomes positive earlier. So based on the analysis, project A is better project and should be recommended. Thank you.